Hey there, welcome back. We're going to learn another couple factoring techniques today called a quadratic form and then grouping when we have more than 4 terms. So our objective is how do I recognize a quadratic form, then how do I solve quadratic form equations, and then how do I factor by grouping. So a quadratic form is a trinomial where the exponent of the second term is exactly half of the degree of the polynomial. All right, and the third term is a constant. So if we look at number 1 here, I'm going to use my highlighter. I have an x squared as my second term, and it is exactly half of the degree of the polynomial. This polynomial is a degree 4, and my second term is degree 2. All right. In problem number 2, I have an x cubed as my second term, and my first term is twice that, x to the 6th. This is a quadratic form. X to the 8th is my degree. 8 is my degree. My second term is x to the 4th. Okay? And it doesn't always have to be whole numbers. This is x to the 1st, and the degree of my second term is x to the 1/2. All right, now there's 2 approaches to this, and there is a thing called U substitution. All right, and I'm just going to highlight this quickly because the problems that we're going to be dealing with, you don't have to do a U substitution, but in case you see it on some kind of high stakes test, I want to make sure that you have seen it. All right, so what you could do is you could rewrite this. If you let u equal x squared, then u squared equals x to the 4th. So you could rewrite this polynomial as 4u squared. Sorry, that looks bad. Four u squared plus 6u plus 9. Then you could do everything like factoring. You could do completing the square. You could do quadratic formula on this and then substitute back in at the end. All right. One really significant use of this U substitution or writing in quadratic form is when you do differentiation and when you get to calculus. So the problems that we have, you're not going to have to actually do the U substitution. So this is the extent of what I'm going to show you. So in this one, if I let u equal x cubed, then u squared equals x to the 6th, and I would get u squared minus 29u plus 100. All right, that would be a u substitution, or writing it in a quadratic expression. This, I would let u equal x to the 4th. That means u squared is equal to x to the 8th. So this would be 4u squared minus 5u minus 6, and so on. Okay, so one more thing I want to show you, this bottom expression. This is not a quadratic form. Notice that this exponent here is not a 2, so it would not follow a quadratic form. All right, now let's remind ourselves how to factor a quadratic. All right, we're looking for 2 numbers that multiply together to give me a times c, which is -4. So it multiplies to equal -4 and adds to 3. So I'm going to use +4 and -1 because that 4 plus -1 equals 3. And so I'm going to rewrite that middle term as -1x plus 4x. So I get x squared minus 1x plus 4x minus 4. right? Remember that we grouped them? And then we factor out the greatest common factor. This is x times x minus 1, and this is 4 times x minus 1, and then I factor out my common binomial, and then I get x plus 4. We did this back when we were working just with quadratics, all right? We're going to apply the same process, only we're going to have an x to the fourth and an x squared. So think about this. In order to get to x to the fourth, I have an x squared and an x squared, okay? So when I go to rewrite my middle term, I'm going to have x squareds in there. I'm still looking for two numbers that multiply to equal 1 times 100 is a positive 100, and add to negative 29. Only now they have x squareds on them, okay? So this is negative 25 and negative 4. Those two numbers sum to negative 29. And so here's how I rewrite it. X to the fourth minus 25 x squared. Now watch how I put this little extra plus in here. Plus, and I still have some of you not doing this and making mistakes. And then negative 4x plus 100. Okay? Now let's group it and factor out. I'm going to factor out an x squared, and that gives me x squared minus 25. Then I'm going to factor out a negative 4, and that gives me x squared minus 25. Now I'm going to factor out the common binomial. Then I get x squared minus 25 and x squared minus 4. Now notice this is a difference of squares. Both of them are. X squared's perfect, 25's perfect. X squared's perfect, 4's perfect. Difference of squares. So I get x plus 5. This is your difference of squares shortcut. X minus 5. And then x plus 2 and x minus 2. Just like that. Okay? Why don't you guys try this one on your own and then come back and we'll go through it step by step. All right, here we go. I'm looking for two numbers that multiply to equal negative 64 and then add to equal negative 63, okay? So that's going to be negative 64 and positive 1. So I'm going to rewrite my middle term. So now I have 8x to the 6th minus 64x cubed plus 1x cubed minus 8 still equals 0, okay? Now I'm going to group, and now I'm going to pull out an 8x cubed, and that's going to give me x cubed minus 8, and I'm going to pull out a 1 here, plus 1, x cubed minus 8, all right? All right. And then we're going to keep factoring. So I have x cubed minus 8. And then I have 8x cubed plus 1. Now I have sums and differences of cubes. Sorry about that. All right, now I'm going to keep going. This is the difference of perfect cubes. So I'm going to get x minus 2, and then I'm going to get x squared plus 2x plus 4. All right, and then this one is going to be 2x and a 1, so I get 2x plus 1, and then I'm going to get 4x squared minus 2x plus 1. All right, now right now we're just factoring, even though it says equal to 0. We're just factoring. All right, and remember, this one and this one are not factorable. They're not factorable when you use the sum and difference of cubes. Okay. All right, now we're going to solve. So what we're going to do is we're going to use those techniques to factor, and then we're going to set each of our factors equal to 0. Okay, so I have 4x to the fourth plus 15x squared plus 9 equals 0. So now I'm going to keep going once I'm done factoring because it's asking us to solve. Okay, so I'm looking for two numbers that multiply to equal, what, 36? And add to equal 15. So that's going to give me 12 and 3. So I'm going to get 4x to the fourth plus 12x squared plus 15, I don't know, plus 3x squared plus 9. All right, now I'm going to group, and then I'm going to factor. So I'm going to take out a 4x squared, and that's going to give me x squared plus 3. And then I'm going to pull out a 3, and that gives me x squared plus 3. Then I'm going to get x squared plus 3, and then I'm going to get 4x squared plus 3. Okay, now these are sums of cubes, and remember we don't have a special factoring technique for those, so we're going to use the square root property on the sums, on these sums. All right, so x squared plus 3 equals 0, and 4x squared plus 3 equals 0. So I'm going to push that 3 over. So I get x squared equals negative 3. And now I'm going to take the square root of both sides, and I get x equals plus or minus I root 3, just like we've done before with simplifying negative radicals. Okay. Right, and then for this one, I get 4x squared equals negative 3, x squared equals negative 3/4, and then I get x equals plus or minus I root 3 over 2, because 4 is a perfect square. So those are all my solutions, and they are all imaginary. Okay. All right, you try this one on your own, and then come back and check your solution. All right, I'm looking for two numbers that multiply to positive 15 and then add to negative 8. Can't hardly read that, can you? Okay, that's a multiplication. Sometimes it just fills in nicely and other times not so much. So positive product, negative sum, these both have to be negative. So I'm going to rewrite it as x to the fourth minus 5x squared. And then I'm going to do this little plus or minus 3x squared plus 15. And I am set equal to 0 and I'm being asked to solve. Okay. So then I'm going to group. And then I get x squared times x squared minus 5. And then I'm going to factor out a negative 3 minus 3 times x squared minus 5. Again, that's equal to 0. Okay, I'm going to factor out the common binomial. So I get x squared minus 5 times x squared minus 3. And again, these are not difference of squares, so I'm going to use the square root property on each of those. So I get x squared minus 5 equals 0. You could use the quadratic formula, but you're going to get the same thing. And then x squared equals 5, and then x equals plus or minus root 5. There's two real solutions there. They're irrational. X squared minus 3 equals 0. X squared equals 3. X equals plus or minus root 3. So this would be root 5, 0. Negative root 5, 0. And then root 3, 0. And negative root 3, 0. Okay, those would be your 4 solutions. Notice again that the number of solutions that we're getting always matches the degree of our polynomial. Okay, now we're going to expand our knowledge of factoring by grouping when we have more than 4 terms. Let's say we have 6 terms. This only works when you have an even number of terms. All right. So what you're going to do is you're going to group the first 3 and then the last 3. You're going to factor out the greatest common factor, which is x for this one. And then we have y for this one. And then notice how this is a match to this. So then we're going to factor out that common trinomial. And then what's left is our other factor right there, x plus y. It's just a straight extension of when we do it with 4 terms. All right. Why don't you try this one on your own, okay? And see how you do and come back and check your work. All right, I am going to group the first 3, and then I'm going to do this little thing that we've done with all of them. I'm going to tuck that negative inside there, okay, because that helps me figure out what to factor out. I'm going to factor out of the first 3 terms a 2 and an x, and that's going to give me k plus 2m minus n. And then I'm going to factor out a negative 3 and a y, and that's going to give me positive k plus 2m minus n, and now I have a match. And so I get k plus 2m minus n. That's what I factor out, and then my other 2 my other binomial comes from those outer factors, just like that. Okay? And here is our daily assignment. Thank you for listening and watching. I'll see you tomorrow.